converter. In this topic, we will cover that what is boost converter and how this circuit will work, the explanation of it, the waveforms of each components in the circuit, and moreover, we will discuss the mathematical equations which will generate through this circuit. So let's start this. What is boost converter? Boost converter is something when we are having lower amount of voltage at input, and this circuit will boost up that voltage and we are getting high amount of current at the output. How this thing will happen? Like we are giving 3 volts at the input and at the output we can get 15, 10 or 12 voltage. This thing can be controlled by this MOSFET. So let's start now. We are going to consider that this MOSFET is on. On mean this MOSFET switch is active. It means that we have some voltage at its base or at this gate due to which the current can flow through this path. While keeping this thing in our head, I will explain you this thing. When the current will flow from the battery to the inductor, as we know, as we already have understanding, from any wire when the current passes, magnetic field generates around it. But that magnetic field is so weak that we can sometimes ignore it. But in this inductor, we have a big amount of turns of coil, due to which it has a big amount of impedance here. So current need to be increased or the current needed to be changed to pass through this inductor, due to which a big amount of magnetic field generates around this inductor. But inductor don't like to change its behavior, due to which it generates back EMF. So that back EMF will resist the flow of current through it, due to which you can see the polarity of inductor is something like this. Plus sign this way and minus sign is this way. But a time will come when a much amount of current will pass through the inductor and it can flow through it. At this point, current will see the easiest path through this MOSFET, so it will flow this way. So when the time, like T on mean on time of switch, so the current flows through this circuit like this, current will be very high. In the same time, the output voltage and the output current will be zero because the current is not flowing in this circuit. In second path, when we turn off the switch, like when we will not give power to this ground or to this gate or to this base, then this MOSFET switch will turn off or it will become non-active. Then what will happen? That is the second part of this circuit. When it is off, a huge amount of magnetic field which is already generated or induced on this inductor, that energy will flow through this diode, drop on this load. It could be load, voltmeter or whatever. So it will take this path when it is turned off. That is the reason that we, when it is turned off, like when the MOSFET switch is turned off, we can consider that just for understanding. Right now, just imagine that we are having two sources here. One is this one is this one. That's why output voltage will become voltage at inductor plus voltage source. That's why the output voltage will increase as compared to the source voltage, and the current flow through this output will be equal to the source current. Now we understood that how this output voltage will become more or increased as compared to the input voltage. You have to understand this thing. If you have not understanding of the MOSFET or for NPN transistor how it works, then I have already gave you the link in the description where you can have a complete understanding of this MOSFET or NPN or PNP transistor very well. Let's see this, the first one. When the current will flow through this inductor, you will see initially the current is low, but it needed more current. That's why the current is changing and go to the another level, from this level to this level when it was filling this inductor, or when the time is on. Like time on mean when the MOSFET was on. And when it was turned off, like when the MOSFET was turned off, then the magnetic field or the energy is dropping its power or energy on the output. That's why it was decreasing in the off state. At the same time, when it was filling, or when the current was increasing, that's why the current through the MOSFET will increase, not quickly, but as it was increasing through the inductor in the same way. That's why these two waves are same. And in off state, this path is already open or like not connected. That's why you can see this is zero. The current through MOSFET at off time is zero. Let's take the next wave, which is output wave. As I already told you, when the MOSFET switch was on, nothing was passing through here, so the output current will be zero at on time, but at the off time, the same amount of current will flow through this output as it was from input source. So Is will be is equal to Io. That's why this wave and this wave is same. Now let's talk about what is happening in the whole cycle with diode. And just consider this thing that I am just taking one cycle, like one on cycle, one half cycle. In total, it will become one cycle. So the voltage through diode when it was on, it was zero. But obviously, when the magnetic flux was getting discharged through this diode, it will be like this. So it will be higher. In the same way, the output voltage or the voltage through the load or the voltmeter will be adding VL plus Vs like this. It will be more than the input. So I hope so till this point you have a complete understanding how we can get the higher output as compared to the lower input. Now from this circuit we will generate some equations. If you are interested in all these equations, then you can continue. Otherwise, this is the final formula. V out is equal to voltage source into 1 over 1 minus alpha. This is the final formula which we will get through this whole calculations or whole equations. And all these equations are so simple. You can get these equations just from this circuit. And one thing is very important. As I told you, you can control the output of this boost converter by giving a different on time and off time at this MOSFET gate or NPN base. You can have NPN base or whatever it is. Just imagine it is having emitter base collector, something like this. We can call it gate or base. The time by which we will turn on and turn off this MOSFET, this will decide what will be the output of mine for this circuit. So you have to have a complete understanding how the MOSFET will work here. Let's go to the calculation part. Here we can consider that energy stored by inductor during on time, like the energy stored by inductor during on time, and the energy released by inductor during off time, or energy collapse by the inductor at off time on this output. Let's take the equations. E1, like the energy will be VL, voltage at inductor, into current into T on, like time on. In the same way, E2 is equal to VL dot I dot T off. I will make it a bit quick. This current will be the change of current. Here, the change of current will be I1 plus I2 divided by 2. From this point to this point, the current changes. That's why I put here this formula. In the same way I put here. Then what is VL? V naught is equal to VL plus Vs here. Here VL will be, put this Vs on this side, and I just put the here. Considering system has no other losses, So like the constant or something, we keep it like E1 is equal to E2. In this way, we are putting these equations here, cross this one with this one. We are going to simplify and rearrange all these equations, and we can come up with this one V out into T off from here, and we take the Vs common from here and here with this equation. In total, we come up with T on plus T off is equal to T, complete time, like complete duty cycle. Yes, we can say just complete pulse, not a duty cycle. Then we just put this T here. This thing will become T, V naught is equal to Vs into T over T off. In the same way, this T off can be T minus T on. We can just keep it like this. And from whole these three things, T over T minus T on, we take a common as a T. Like total pulse, we take it as a common and we will having a T on over T. This is the duty cycle. And what is duty cycle? Duty cycle is just the on time divided by total pulse. Then we can change, like we can represent the duty cycle with the help of alpha, as you can see here. So that is the final formula. Now, I will give you one example that how you can change or how you can control the gate, the amount of time for on and off for this MOSFET and how the voltage will change. Let's see now. This is so interesting thing. Turning on this MOSFET for 3 seconds and turning off this the same MOSFET for 3 seconds. Let's keep it like this. Obviously, this thing happened in milli or microseconds so quickly, but just for your understanding, I am just taking seconds only. So you can put this value like 3 over 6 here or anywhere. Then this T on over T will become half 1 over 2. Put here 1 over 2, then solve this equation by putting 1 over 2 here. You will get V out is equal to 2 Vs. It means that if you will turn on this gate or this MOSFET switch for 3 seconds and turn off for 3 seconds, then output will be 2 times of source voltage. Obviously, you can also change it, and the alpha value will always remain between less than 1 and more than 0. This is the thing you have to understand. Now you can, by having a bit understanding of little programming, basically you can make thousands of hundreds of circuits. Just another example of duty cycle. If the turn on time is like this much and turn off time is this much, in this way we can consider the duty cycle is something around 25 or 30%. So this is the whole thing. I think you have complete understanding of boost circuit with turn on time, turn off time, all the waveforms for it and the equations and the final result. And if you have any question, you can ask me in the comment or in any other electronic component or circuit or project you want me to explain, you can write in comment, I will put it. Thank you for the understanding and subscribing and sharing my channel with others.